Good morning. My name is Sooyoun Park. Today I'm going to talk about our project, Lightweight Transformer Super Resolution. This is joint work with Dokyun Kim, Gyeongseon, and Soyeon Park. We suggest a lighter super resolution with moderate compression, and I'd like to share our work and results in detail. Okay. The image super resolution is task of enhancing a low resolution image to higher resolution. Deep neural network has brought a lot of improvements in super resolution, and various network architectures have been introduced. However, most of them are very deep and complex, requiring high computational cost and memory consumption. To address this problem, we suggest computationally efficient super resolution model by applying model compression techniques. Our baseline model is transformer-based super resolution, Sooyoun. Sooyoun is composed of Sooyoun transformer, which is a variant of Vision transformer, VIT. With this as our baseline, we applied two model compression techniques, knowledge distillation and network pruning. By far, many have attempted to compress CNN-based super resolution models, but transformer-based super resolution compression is rarely found. First of all, knowledge distillation is transferring knowledge from a large network to a smaller network. The small network, so-called student, is trained to mimic the exact behavior of large network called teacher. This is a technique that does not explicitly compress the model, meaning that it keeps the dimension of network. This is the general structure of our model, and in our super resolution task, as represented in the figure, the student network is trained to learn from both the output images of teacher network and ground truth high resolution images. Network pruning is removing weights from an existing network. There could be many redundant connections within a network that does not affect the performance. Pruning is removing those weights. Here we use channel pruning method, and we cut the less important channels of each transformer block in Sooyoun. I'd like to share our results. We upscaled 127 by 84 dimension images by scale of 2, and we evaluated the performance by metrics called PSNR and SSIM. These scores are higher the better. In knowledge distillation, our teacher model is original Sooyoun containing 36 transformer blocks, and our students is a small model containing 24 transformer blocks, and the student is trained to learn from the teacher. As a result, the performance improved by 0.24 PSNR compared to the model that is trained without teacher model. Compared to the original model, knowledge distillation showed small drops in PSNR, even with 13 times less number of parameters. The image shows the transition from low resolution image to higher resolution, and we can see the edges became more clear with the knowledge distillation model. As a result of pruning, when pruned 25% of feed-forward and attention layers from transformer blocks, pruned model outperformed the original model in some dataset. Interestingly, even pruning 75% of channels from feed-forward layers did not damage the performance very much. PSNR dropped only by 0.59. The images show that pruning also helps smoothing the edges of low-resolution image. To summarize, we proposed a lightweight super resolution and successfully demonstrated the effectiveness of model compression. As far as we know, this is a very new approach to applying model compression on transformer-based super resolution. We think different compression techniques can also be effective as well, and it would be an interesting task to further reduce the parameters, combining several methods. This is the end of our presentation, and thank you all for listening.
Thank you. Any question? So yeah, I have a comment. I read just skimmed your paper for grading, and it looks like the result is really good. But it could have been better if you actually more emphasize that the student model is just as small as 1/13 of the original teacher model size.
Yes.
So yeah, it was great. So what is the biggest novelty or contribution in one sentence?
I think that there are many CNN based in super resolution, and some model comparison techniques have been applied on the CNN based models, but it is a very new approach to apply on the transformer based model for super resolution. And yeah, I think this is our novelty.
Great. Okay. Thank you very much.
Thank you.